Hello class, we are on Module 4, which is the skeletal system, physiology, and movement. Guess what? This is our first video lecture, and this isn't my favorite way to teach. In fact, I really do not like teaching online. I just don't like it at all. It feels weird. I like seeing all of your faces and moving around and talking and not just staring at a computer screen and talking to the wall. It just feels really strange. But we're going to do it because we only have 1 week to learn all of this material. So I'm going to cover half of the lecture right now, and the other half we're going to do on Monday. So please take out your notes, put on your thinking cap or whatever your mom calls it, and we are going to get into this material. It's one of my favorite chapters. It's very complicated, but if we put on a little bit of effort to learn it, it's one of the most beautiful things to learn, and it really portrays God's creation almost better than any other subject in anatomy. So I don't remember what we named the little dude that I bought from the Dollar Tree that was hanging out on the whiteboard, but that's him. He looks a little better now. He got a remodeling. So he's saying, "Saw, dude." He says, "Can you guess what I'm made out of?" Have you ever thought about what your bones are made out of? They look like just rocks that really just support your organs and help you move and muscles attached to them, but that's not all they do. They do that, but they are super complicated and they're an organ system in themselves, and they do lots of complicated things just like all your other organs do. So let's find out what exactly they do. Please take your notes. And so the first question is, what are they made out of? They're made out of bone matrix. It's the magic mix of water, collagen, and hydroxyapatite. That's fun to say. Not really. 1/4 of your bone is made out of water. And when people say, "Dang, that desert is just bone dry, man," that's really stupid, because bones are not dry. 25% of them is made out of water. It's the opposite of dry. So, and another 25% is collagen. Remember, if we talked about collagen fibers are like ropes. They're really, really strong, but they're also very flexible. So if I took on one of you guys in a tug-of-war competition, if I had a good brand new rope that's not a bad rope, the rope wouldn't snap in half when we're pulling it. One of us would pull the other person over or rip the rope out of the other person's hands, but the rope wouldn't rip in half unless that's a really old and broken rope. The last 50% is made out of bone salts, okay? Bone salts or hydroxyapatite. So what hydroxyapatite is, it's 40% is calcium and 20% is phosphorus and other things like lead and gold. You actually have gold in your bones. So you're golden, you really are golden. What hydroxyapatite does, though, it's like concrete in the fact that it gives your bones that really strong compressive strength. So a little example of this is if you take a chicken bone and you scrape off all of the actual muscle and everything from the chicken bone, and you just have a chicken bone, and you throw that chicken bone inside of a cup of vinegar, and you leave that for about 48 hours. What's going to happen is that vinegar is going to eat away that hydroxyapatite, which is calcium and all that stuff. And all it's going to be left is that collagen and some other stuff. But what's going to happen is it's no longer going to be hard. That bone is not going to be hard anymore. It's going to be like a rubber band almost. It's going to be very flexible, and you're going to be able to move it and bend it in all kinds of weird, funky ways. And I really hope you guys try this because it's really interesting and fun if you haven't done that already. So just remember that, though, when that vinegar is actually eating that hydroxyapatite, which is that strong compressive strength like concrete. So let's talk a little bit about bone cells. So there's 3 main types of bone cells. There's the osteoblast, osteocytes, and osteoclasts. So your osteocytes are that little spider-looking thing on the left. Sorry that the picture isn't the best quality. What they do is they form bone. So looking back here, they lay down all this bone matrix and make new bone. By the way, here, this picture on the right, you don't understand that yet, but you'll understand it hopefully by the end of this lecture. Second one, osteocyte, is a mature bone cell that makes his home inside his little lacunae matata house. So this is the little story of the bone cell. So Mr. Osteoblast, he's an aspiring youngster that is very busy working down. He lives on the outside of the bone right here. And, oops, He lives on the outside of the bone, and he's always laying down new bone material. So when he retires, he becomes an osteocyte. And osteocytes, you see, follow the arrow, they're a little bit farther back inside the bone than the osteoblast. And what they do is they make their permanent home, they go into their retirement communities and just live as part of your bone. And they're not laying down any more bone anymore. They're a mature bone cell. They're done. They lived their life, they finished it, and they're going to become a nice little retired osteocyte. An osteoclast is a cell that breaks down bone matrix. And you wonder why in the world would you want a cell that breaks down your bone? And it's a little bit complicated to explain right now, but we're going to talk about it later. It's very important, especially for your blood and everything like that, okay? So let's move on. These are just the basic terms that we talked about. If you want to review these and pause the video. The experiment that I mentioned there, again, just pause the video. These are everything I just talked about. All right, moving on to what a femur would look like, a long bone, if you cut it in half. And we're going to talk about compact and spongy bone. So cancellous bone is on the inside. It's that spongy looking red stuff that it's pointing to. That's spongy bone. It's inner bone and it's porous, like a sponge. So what it is, it's a network of bone with many marrow-filled spaces surrounding the bone matrix. Have you ever broken apart a chicken bone and you saw all that red stuff inside? That's the bone marrow, okay? That's your spongy bone. The compact bone is the outside part. It's the outer bone and it's rigid. It's the dense bone matrix organized into microscopic tubes called osteons. And we'll get to talking about that in a second. It's very dense, very, very dense. It's very different than spongy bone, okay? So let's talk a little bit more about spongy bone. So the little lattice work there that you see, all of that spongy lines that are just going throughout the top there, that's called the trabeculae, or trabeculi. It's the term for the intricate and spongy looking bone. So the open space contains red bone marrow and blood vessels. So I told you guys a while back that bones are actually, a lot of blood is in the bones, and they actually create the blood that is in your body. So that red bone marrow actually produces red blood cells in a process called hematopoiesis. So we see here, if you're going to, let's go to the far right, the image on the far right, that is a magnified image of one of the trabeculae. And you'll see the little lacuna matata, one of the osteocytes that is mature, and he's all grown up and happy. Then you have your osteoblasts. If you go down a little bit, those are the little cells that are on the outside. They are busy working, making new bone. And then your osteoclasts are little bone breaker guys. Okay? Let's move on. A little bit more about spongy bone. Again, the inner lattice work is called the trabeculae. The spaces in between the bones contain bone marrow and blood vessels. Spongy bone is actually hard and strong, interestingly. It's not spongy. That's the only thing that's not really like a sponge about it. It's actually very strong because it's, again, made out of bone. So if you want to just take a look at that, again, you see your osteoblast on the outside, your osteoclasts, and the little guys on the inside are the osteocytes chilling in their lacuna matata. Now we're talking about compact bone. So what I'm going to actually do is have you guys right now, not later, right now, yes, right now, pause the video and turn to page 115 through 106. All right, so turn your eyes to figure 4.3, which is on page 115. So we're going to talk about some of these terms here. And the reason I'm making you guys look in the book is because online everything was way too complicated and the book made it pretty simple. So an osteon is that little, that tightly packed cylinder that you see there. It's on the top of the figure. And they're made out of lots of osteocytes chilling in their little lacuna matata. Okay, they're formed in circles, circular things called lamellae. So lots of lamellae in a long chain make those osteons. Okay, lots of those osteocytes make lamellae. Anyway, let's talk a little bit more about those. We have the central canal, which is a hollow tube that blood vessels run through, all down through the femur or whatever long bone it is. It goes all the way down, and they are in the middle of each osteon. Your concentric lamellae are tubes of bone tissue that run through the central canal. So those are lots of those osteocytes going with the big osteon. The interstitial lamellae are tubes of bone tissue that go everywhere else. So if you look how it's pointing at the interstitial lamellae, it's not really in a nice circular form. It's just kind of around the osteons. So the ones that are in the osteon, again, that's the concentric lamellae. The ones that are around it but aren't part of the osteon, that's the interstitial lamellae. And if you see, you see on that figure that there's lots of those blood vessels going through, and that explains why if you break your bone, there's a lot of swelling and everything turns all purple. It's because you're really internally bleeding when you break a bone. Your bones bleed when they break because there's lots of blood going through them. A little bit more on the basic anatomy. And in order to understand, we have to understand this if we're going to understand bone growth. So please pay attention and pause the video until you understand this. So let's dive into this. The two ends of the femur, there's the top of the femur is on the far left and the bottom is on the far right. The two ends are called the epiphyses. The epiphyses contain spongy bone or cancellous bone. And on each end, we have this thing called articular cartilage, and it's cartilage that pops into a joint and it provides lubrication and helps your bones move without grinding against each other. That would be bad. And then you have your epiphyseal plate. The epiphyseal plate is also made out of cartilage, and that is the center for bone growth. And we'll talk about that in a second, but all bone growth occurs at the epiphyseal plate. They call that your growth plate, and if you break your growth plate as a kid, you have a problem, and it often requires surgery to fix it. And in the middle, you have this little sandwiched out area called your marrow cavity, and that's where your body stores yellow marrow and red marrow. Okay, you have your periosteum, which is the outside there, and then your compact bone. And your compact bone is, we looked at that just a second ago. All right, great. Let's go on. Oh, by the way, forgot to mention, the diaphysis is this middle portion here. So the epiphyses are the outside, and the diaphysis is the inside. Okay, flat bones look a little bit differently. They look more like a sandwich. You have the spongy bone on the inside, and then the compact bone on the outside, and the periosteum on the very outside. All right. See this guy here? Oh, hold on. All right. He says, am I screaming in agony or so happy that I can't contain myself? What I want you guys to do is, I'm testing again if you're watching this video. I want you to contact me with your answer to gain an additional 2% extra credit on your most recent exam. Again, I reward those who listen and actually will watch this video and learn from it. So please tell me if he is screaming in agony or if he is so happy that he can't contain himself. That's your choice. There's no right or wrong answer. Okay, now we're going to talk about ossification or bone growth. This is probably one of the hardest concepts to learn if we're just talking about single concepts in anatomy, but please pay attention, watch the video, look up other videos on YouTube to help you understand it more if you need to. So young bones have epiphyseal plates. We just talked about those that separate the epiphysis from the diaphysis, and those are made out of hyaline cartilage. That's step one. Okay, so you see that resting cartilage at the top of the diagram there. That is hyaline cartilage. Okay, so then number two, it says those cartilage cells that are closer to the diaphysis. So that are closer to the diaphysis, remember the diaphysis is the middle portion, that are closer to the diaphysis grow and their lacunae houses get bigger. So going up to the top again, it's really hard to explain this, by the way, without being in person. So I'll do that when we do the review game more. So we have your resting cartilage, and then you have that multiplying cartilage. See those little circles in the multiplying cartilage? Those are the lacunae. Okay, they're getting bigger and 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 bigger. Remember, so your bones start out as cartilage before they turn into bone. And number three is bone salts, or hydroxyapatite, as discussed earlier. They invade these little lacunae matata houses, and they get calcified. So maturing cartilage right here is the third one, and that's when the lacunae are really big, and then guess what? They get invaded by hydroxyapatite or bone salts. And this is called, when this happens, it's called calcified cartilage. So the bone cells get invaded by hydroxyapatite. And so going down to step 4 is remember that cartilage has no blood vessels, but bone actually does. So the blood vessels from the bone bring in osteoblasts and osteoclasts. So God created the body to know that when you're forming bone, you need osteoblasts and osteoclasts. So the blood vessels bring in these cells. Like it's a little transportation here. They bring in those cells. We're here, we're coming to the rescue. We're ready to build bones. The blood is the transportation system of the body, and we'll talk more about that when we get into blood. But anyway, they bring in osteoblasts and osteoclasts. And I'm going to actually move this guy down here so you can see the bottom here. And step 5 is the osteoblasts begin laying down bone matrix on top of this calcified cartilage and form cancellous or spongy bone. So you notice the whole entire thing is actually all spongy bone when it starts. And then later the bone remodels and becomes osteoclasts actually start breaking it down, and osteoblasts build it up again, and it becomes compact bone on the outside. So let me explain this one more time in a way that kind of makes more sense. So again, direction of bone growth goes in those arrows, the arrows that are pointing there. It starts resting in the epiphyseal plate. Okay, that's just all hyaline cartilage. Then the cartilage cells start multiplying like madmen and become mature and get bigger and bigger and bigger. And once they're really big, now that hydroxyapatite or bone salt invades it, it becomes calcified, and that middle portion there is mature, spongy bone. Okay, I'm going to go over that a lot more in class because this is a very complicated concept, but if you guys understand it right now, that's awesome. If you don't, please watch some videos. I know Crash Course explains it really well. There's lots of other videos on YouTube that will explain this thing. So it's called ossification or bone growth. Please Google it and watch a video this has a lot more imagery than I could bring you. All right, we're talking about more bone growth now. So during the process, the epiphyseal plates do not change in thickness until they are mature in height and they become solid and ossify. Ossify means they are done. Okay. At that point, the epiphyseal plates becomes the epiphyseal line. So when you guys are done growing, a lot of you maybe already are, your growth plates will fuse, is what it calls, and now you're no longer laying down new cartilage cells that will turn into bone. It's done. You're grown. You're completely done. The opposite of this is called appositional bone growth. And appositional bone growth grows in diameter. We were talking about growing in length. Appositional bone growth is growing in diameter, and it's a lot more simple. All it is pretty much just the osteoblasts lay down new bone matrix on the outside. Okay, it's not the whole super complicated process. So let me ask you, why is it bad to break a growth plate? Is because breaking that growth plate disrupts the whole process and can actually cause one bone to be less big or less long than the other one. Okay, that growth plate or the epiphyseal plate is the factory pretty much for the growing bone. Now let's talk about bone remodeling. So all compact bone begins, again, I talked about this, first as cancellous bone or spongy bone, and then is remodeled. Osteoclast, bone destroyers, and osteoblast, bone builders, respond to what your body is already doing. So this is actually really interesting with bone remodeling. When you're active, so if you decide to go on a run, your osteoblasts are working harder. They're actively laying down new bones. So when you go work out at the gym. So if I'm going to work out the gym and I'm doing tons of squats and bench press and deadlifts and all these crazy workouts, I'm not only building muscle, but I'm also building bone mass. My bones will actually get bigger and stronger when I'm working out. And the opposite, if you're inactive and you just chill and do nothing and watch Netflix all day long, then you're getting no pressure to your bones, and your osteoclasts actually start removing some bone. Again, you're wondering, why in the world did God make osteoclasts if they're just going to remove bone and make you weak? We'll talk about that on part 2 lecture on Monday. So osteoclasts secrete this thing called proteolytic enzymes, and what happens with that is they digest that collagen and start eating away that hydroxyapatite. So again, please remember that when you're active, your osteoblasts or bone builders are continually laying down new bone, and when you're inactive, you're losing bone. That's called bone remodeling, or another term for it is Wolff's Law. This guy named, last name with Wolff, figured this whole process out and termed this as Wolff's Law. Anyway, space gravity is only 1/6 Earth's, and this could create a big problem to our bones because your bones are used to having all that gravity and force pushing on them. So your osteoblasts are actually laying down new bone and keeping your bone strong. Okay? But when you have only 1/6 of the gravity of Earth, you start, your body just feels like, oh man, he's just not doing anything because there's no gravity forcing pressure on the bones. So you start losing 10% of your bone mass every month that you're in space. That's crazy. So in 10 months, if you literally were a couch potato in space, you'd pretty much lose like all of your bones, okay? It's very, very dangerous. That's why in space, in the space stations and stuff, they make you work out a lot. They do lots of rigorous workout exercises because they want to maintain that bone mass, because it's a huge problem if you start losing 10% of your bone mass every month. So that would be the solution, is working out and yeah, drinking lots of milk and maintaining that calcium, and so you don't lose all of your bone mass. All right, guys, that's it. I know that was a little bit tedious and tiring. I really hate watching online lectures myself, but you guys did it. Please come to class on Monday with that study guide. We're going to cover that second portion of the lecture, and we're going to do lots of review activities to enforce all this stuff, because I know it's really hard to learn when you're just staring in front of a computer screen. All right, I lost my voice for some reason. I will talk to you guys on Monday. If you have any questions, don't hesitate to contact me. Also, make sure you respond with this. Don't forget about that, okay? And that's the extra credit. Hopefully you're watching that and you contact me about it. All right, I will see you soon.